This is section 7.3, solving systems by equation using addition and subtraction. So far, as an overview, we've solved these systems with two types of processes. The first has been graphing to see where two lines can cross. They either crossed in a point, if you remember, or they were parallel lines, or they laid right on top of each other and the graphs touched continuously. The second method that we used to solve systems of equations was using the substitution method by replacing one variable with another variable. That was yesterday's material. Today we're doing the third and the final method of solving a system of equations. It is using the method called elimination. By elimination, what we mean is we're going to eliminate one variable in the first or second step of the problem, leaving us a new equation with only one variable. Our steps to do this are listed at the top, as you can read through on your own. We're going to go back to those and refer to those in just a little bit, but right now we're going to look at step 2, because in our first problem, this is the one that applies. That's add the equations together to eliminate one variable, and we're going to solve for this variable. You can jump right to this step when you look at your two equations and you notice that one of the two variables are exactly the same except for the coefficients are opposite. By coefficients, remember, that's the number in front of the variable. So here we have 6x and negative 6x. So we're going to look at this vertically as an addition problem. We always use addition to work out these kinds of problems. So we're going to add these up together, and the x's drop out completely. When we add up the y's, we only get 2y on the left, but we get 6 on the right. This really simplified the problem because now our x's are eliminated. Once again, we added them up vertically to get this resulting equation. We now divide both sides by 2, giving us a new equation of y equals 3. In many cases, this is much faster than graphing or substitution. Now, just like we did in substitution, we're going to have to find the value of x. We have to choose either the first equation or the second equation to try to use to plug in to find the value of x. I'm going to choose the first equation because the 6x is positive. So I'm going to write down my first equation, 6x minus 3y equals 3. I now take my value of y, and I'm going to plug it into that same equation, and that value of y is 3. So write down with me 6x minus 3, parentheses, leave a space, equals 3. In that parentheses, we're going to put the value of y, which in this case is 3. It seems we have a lot of 3's on this problem. We now need to solve for x. To solve for x here, very simply, we're going to multiply things out and get the x by itself. So we have 6x minus 9 equals 3. What are we going to do next? Move the 9 over to the other side. Because it's a negative, we have to add a 9 to both sides. Our resulting equation is 6x equals 12. Now we have to solve for x finally by dividing by 2. Dividing by 6, because our answer is x equals 2. We now have the second value of our variable, y equals 3 and x equals 2. We have to check our problem. We use the first equation to solve our problem, so we're going to use the second equation to check our problem. Our second equation, let's write that down now, negative 6x plus 5y equals 3. We're going to replace the x with a parentheses and the y with a parentheses, and we're going to put the values of x and y that we just got, 2 and 3, in those parentheses. As we're continuing to work on this, we multiply 6 times 2 and get negative 12. We multiply 5 times 3 and get 15, and that equals 3. So 3 equals 3, and the problem checks. So once again, these two lines cross in a point. That point is 2, 3.